So Unit 6, our first lesson is on variation, okay? So there are different types of variation relationships, okay? So the first one that we're going to look at is direct variation. So what is my equation for direct variation? Y equals kx. It's like a direct, straight line. It's kind of what I think of, okay? All right. What's important here is your constant of proportionality, and that is your k. Okay? K for constant. All right? So your k is your constant. So here are some key words. How do I know if I get a word problem that I'm talking about direct variation? Well, you would see something like, okay. What does that say?
Directly proportional.
Yep. Directly proportional. Or it may say that. What does that say?
Varies directly.
Good. So with direct variation, that relationship is basically that if your x goes up, your y goes up. Okay? One goes down, the other one goes down. Okay? And that's what that is. You're looking at relationships. If you look at this as a graph, okay, then if they give you a table or if they give you a graph and they say what kind of variation is this, to check and see if it's a direct variation, the easiest thing to do is look and see if your y-intercept is at 0, 0. Direct variation always goes through the origin. All right? And if you look at these graphs, as your x gets bigger, your y is getting bigger. Okay? And here, as your x gets bigger, your y is getting smaller. Make sense? Okay. So it says, okay, so we're going to look at solving a variation problem. So this is the type of problem that you might see, and this is very straightforward. What they're going to do is they're going to tell you, all right, y is directly proportional to x. Okay. That tells me y equals kx. And the next thing you need to do is find the constant of proportionality, right? Find the thing that connects them, that connects this relationship. That's your k. The next statement here where they tell you y equals 15 when y equals 3, this is to help you find k. Because they give you the y, they give you the x, so you can solve for k. All right, so let's plug it in. 15 equals kx. Right? So divide by 3, and k equals 5. All right, there you go. You just found the constant of proportionality. So this was the relationship. The k is the link between x and y. And in the last step, they're asking you, find y when k equals 6. For this step, you need to plug in k to find your other variable. All right? So this one statement is actually like you're doing two different things here, kind of, right?
Why does it find y when x is 6?
Yeah, because you just found k, right? So your original equation was y equals kx. Well, now that you know k, you can say y equals 5x. Right? So then take that and plug in x and you have your k, so you can find y. okay? You always need to find the k.
This is annoying.
So find y when x equals 6.
Y equals 30.
Yeah, y equals 30. So y equals 30 when x equals 6. Yes. Oh, I should be. Yes.
It disappeared apparently.
I know. I was like, oh no. All right. So just to, for some of you guys, let's just make this a real life example. How many of you guys drive? Okay. All right. So several of you drive. All right. So an example of a direct variation relationship, x and y, would be like, if how fast, okay, how many miles you're going over the speed limit and how much you're going to pay on the ticket. Okay, right? Because say a cop pulls you over because you're supposed to be going 35 but you were going 45, right? So if I drive more miles over the speed limit, then isn't my fine going to go up? Right? That's a direct variation relationship. So if this is how much, y is how much I need to pay for my fines, k is how many miles over I am, from the speed limit, and k is how much it is per mile over the speed limit. Like, I don't know. I haven't had a ticket in so long. Like, I don't know how much, how they do it. You know what I mean? I don't remember, but you need to find k because say you were going 3 miles over the speed limit, all right? And you had to pay $15. Okay? Then that means it's $5 per what?
Mile.
Yeah, that's over. So you needed to find that so that in the future you could tell yourself, well, let me not go 6 miles over the speed limit because then I have to pay $30.
Or let me save up this money so I can go over the speed limit.
Oh my goodness, no, absolutely not. No driving for you, okay? But that's what that is. Like, that's what a direct variation relationship is, okay? One goes up, the other one goes up. One goes down, the other one goes down, all right? So that's why you need to find that K, because you have to find that relationship, all right?
$100 if you go 60 miles over the speed limit.
All right, so let's try this one. B varies directly with
Bless you.
C.
Thank you.
So, bless you. B varies directly, okay? And whenever I see varies, I always think you gotta have equals K, all right? That varies tells you gotta have that K. So B varies directly with C, okay? And C equals 3 when B equals 4. They gave you both of those, they gave you values for both of the variables. So this is what you need to do to find K. All right, so B is 4, K, C is 3. So what is K?
3/4.
4
4/3.
thirds. Okay. So I found K. So that means I can rewrite this equation and just plug in my K. So B equals 4 thirds C, right? I needed to plug in that K because look at the next part of this problem. They said, find C when B equals -8. Well then, okay, you can do that because you know K now. So find C, B equals -8. Yeah? How do you get rid of that fraction? Yeah. Yeah, you got to multiply by the reciprocal. So C equals, what is this? -6.
How?
Right? Not bad. Algebra 1. Shouldn't be.
I'm sleepy.
You guys have done way more complicated things than this year.
I know, this is just annoying.
Oh, well, it can be annoying as long as you understand it. All right, then let's look at the second relationship, an inverse variation. Well, inverse, the equation looks like this. Y equals k over x. Okay, it's a fraction.
That doesn't look pretty.
All right. And what is the constant of proportionality? K. That doesn't change. All right. K for constant. So you guys, I hate saying that now, but I for everything. So anyway, the keywords. Okay. Keywords for inverse variation would be well, this one's inverse. Did I spell that right?
Probably.
Is there an E or not? I don't
I don't think there's an E.
think there's an E either. Oh no. Inverse. No, but then that looks weird. I think there's an E. Ugh. I don't know, but you, right? It varies inversely. That has inverse in it. And varies as equals K, right? I think there is an E.
It says inverse.
I think there is an E. Okay. The other one would be. What is the second one? What's another way you might see it?
Inversely proportional.
Inversely
dot, dot,
proportional. Dot, dot, dot.
Why is there a dot dot dot?
Well, because there's more stuff that comes after it, right? And if you were to graph this, right, it would look like this. All right? You basically have these two, I guess like, what do you call that? Parabolas, right? They're like hyperbola?
People just make a food with it.
Sure.
They kind of look like really soft corners.
All right. So, we have 3 minutes, right, before lunch. Let's try this problem. It says M is inversely proportional to P. All right, so that first one is whatever equation I need to be using. So M is inversely proportional to P. Always have to have equals K. Don't forget the K. So the second part tells you how to find the K. When M equals 4, P equals 2. So what is K? Gotta multiply by 2. K equals 8. All right, so let me plug this K into this equation so that I can find M when P equals -8, right? We're going to use K, or use our new equation to find M. 8 over -8.
-1.
Good. M equals -1. So, good job. How is this?
Easy.
You know what? While you guys are at lunch, I want you to do this. Think
You know what?
about an
Pause it.
inverse relationship, an inverse variation relationship. When one goes up, the other goes down. When one goes down, the other goes up. Think about a real life situation where one goes up, the other goes down. Or one goes down and the other goes up. Okay? Let's go back to our lesson. Okay? Wait, hold on. Save it for just a second. Let's do these problems.
Write it down.
All right, write it down. Okay, so let's look at this one. H varies inversely as G. All right, so this one's going to be, okay, let's do this. H varies inversely as G, right? Now they said H equals 1/2, G equals 6. So we can use this to find K. 1/2 equals, yeah?
K equals -6.
Okay, so how do we find K?
Multiply by -6.
Yeah, multiply by -6. So then K equals?
-3.
Good. So we're going to use that new K and we're going to rewrite our equation. Right? So then using that, find G when H equals 63.
-1/21.
What'd you get?
Okay.
All right. So be careful here. When you have a variable in your denominator, right? The easiest thing that you could do actually is you have a proportion. You could make this over 1, cross multiply, right? Or you need to multiply by the G, get that G out of there, okay? But you could cross multiply here. So you have 63G equals -3, right? Fraction equal to a fraction, you can just cross multiply. Divided by 63. So G equals what?
-1/21.
Good. Okay. Any questions? Sorry, there. Negative. -1/21. Yeah? Oh, sorry. 21. 21. Okay? All right. And this was an SOL question.
From how many years ago?
Probably like maybe 3. If y varies inversely with the square of x, you'll love doing that, throwing in square root, cube, whatever, right? Y varies inversely with the square of x, well, it's x squared, right? Yeah. What is the constant of proportionality? So they're saying find the what? K. So find K when y equals 10, x equals 5. Right? And you don't have to do anything else. They just want you to find the K, the constant of proportionality. So this is what?
50.
25. So K equals 250.
That was actually on a real life.
Yeah. So this is the stuff that they will ask you. But if you don't know what the constant of proportionality means, that they're going, wait, right? Or if you don't know how to set up the inverse, and so as long as you know those two things, this is a pretty simple question, right? Okay, so another way that they'll give you guys these kind of problems is they'll use word problems. So this one, and it's fine because you just have to assign variables if they don't, provide them for you. So read your first statement. It says the time it takes to do a job is inversely proportional. Go look for the words. Go look for your key words. Inversely proportional, right? What is? What is the thing that they're talking about in the beginning, like before? The time. Is inversely proportional to what? The number of workers. So there you go. Just pick out your important pieces of information, right? So time we can call T. Workers, we can call that W, or you could call it N for number of workers, right? So T equals K over W, right? Because it's inversely proportional. So look at the next statement. If 8 workers can do a job in 6 days, well, they just gave you W and T, right? T is what? 8 or 6? Good. So 8, right? Times 8 times 8. K equals?
48.
Good. So then now I'm going to rewrite this equation. T T equals 48 over W. Because the thing that they want you to find is how many days will it take for 16 workers to do the same job? Well, what do they give you? T or W?
W.
Good. So how many days will it take?
3.
3.
You
And
could
so
have just guessed that.
if you get a word problem like this, please make sure you include the units, okay? Because if you just tell me 3, I don't know, 3 hours, 3 minutes, 3 days. Exactly. So tell me the units, okay?
Couldn't you just figure that out from looking at it?
Yeah. But you got to apply your variation equations, okay? All right. Okay, so they like giving you these type of problems too. Is it inverse? Is it direct? Which one is it? Or is it neither? Okay? Inverse, we said is y equals k over x. Do you agree?
Mm-hmm.
Direct is what? Y equals
KX.
kx. Okay. Both of those are equal to what?
Why?
Y. Okay, that means for every one of these examples, make it equal to y and see which one it looks like. Is it inverse or is it direct? Or is it neither? Right?
Middle's neither.
Okay, so the middle one is, alright. One is neither one. Not direct, not inverse. This one is not equal to y right now, so what do I need to do?
Subtract by X.
No, not
Divide
subtract.
by x.
Divide. So then you have y equals negative 2 over x. What is this?
That's
This
inverse.
is inverse. Negative 2 is the k here, right? So then what is 9? How do you
Inverse.
solve that for
Times by the x.
good? Times the x.
And that's direct.
Y equals 4x, so this is direct.
So it's middle.
Yeah,
It's kind of
it's just
it's a
an equation
something.
of a line, right? Okay, questions? All right. So, oh, okay, here we go. What are the similarities between direct and inverse variation? I already filled it in. Well, they both have K, right? What do they have in common? Both have K. And for both of them, you have to solve for K. I mean, unless they give you K, but they're, no, solve for K, right? So then what are the differences? Well, direct variation has an x in the numerator. Y equals k x. Excuse me. Technically, if I had to write that as a fraction, it's kx over 1, right? So the x is in the numerator. For the inverse, your x is in the denominator because it's y equals k over x, right?
That's a really weird way to spell demon.
Oh, no, denominator.
No.
I know.
Okay, so graph of a direct variation is a line that goes through the origin, okay? If it goes through 0, 0, okay, it's a direct variation. And the graph of an inverse variation, that is a hyperbola. That's what it was. I said hyperbola. I was trying to come up with the word earlier.
You find this earlier.
I know, I was like, what is this called? I forgot.
Oh,
It's a hyperbola.
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 It's a hyperbola.
All right.
Wait, no.
All right, so the next variation relationship is joint variation. Okay, and joint variation is that.
Oh, it got even more complicated.
Joint variation looks like direct variation because it's all multiplying, right? But you just have an extra variable there. That's it. You're just going to have more variables.
Okay.
Okay? But what is still the constant of proportionality?
Okay.
So let's think of some keywords for joint variation. It'll probably say varies how? Jointly. There you go. Yeah, I think that's it. Varies jointly.
That's the only term that is.
I think so. All right. So let's try this one. Z varies jointly with X and Y. Oh, okay. So, you know what? Go in the order that they give you, okay? Z varies jointly with X and Y. Z equals KXY.
Can we fix that later?
Yeah.
Okay.
Yeah. I know, man. Z equals KXY. But to be honest with you guys, if they use other variables, just go in the order of the variables that they give you, okay? So don't stress about like, oh, I have to memorize, just know what it looks like. Is it multiplication? Is it the inverse? Okay? So here, like they'll tell you, Z varies jointly with X and Y. And remember, I told you whenever you see the word varies, it equals K. All right? So here, when X equals 3 and Y equals 8, Z equals 6. That's what you use to find what? K. All right, so let's plug it in. Now you have more things to plug in. 6, 3, 8.
Do you want to multiply the numbers first and then multiply that to the K?
K times what? 24?
Mm-hmm.
And then divide by 24?
Mm-hmm.
K equals, good. So then I'm going to take my equation. I'm going to plug in for K. So Z equals 1/4 XY.
X and Y do have.
Good. So the next part tells you that you need to find Z when X equals -4 and Y equals 7. So just plug in. So what is Z?
-7.
-7. Good. Questions? Comments? Concerns? All right. Okay, so you know what? Try this.
Did we skip
Can we
one?
go back?
Oh, did we skip one?
That was it.
Oh, number 11. Okay.
She already told
How
you
did
that
that
11
sound?
was missing.
There's an 11.
Oh, is that what she was saying?
Yeah.
Okay. All right. So we'll do 11. And you know what? Actually, why don't you guys start 11? You can do 11.
Are you sure?
Of course you can. Do you feel like you cannot?
Maybe.
Yes.
All right. So Z varies. Remember, varies is equals K. Thank you, Natalie. XY varies jointly with X and Y. When X equals 1, Y equals 1/3, and Z equals 5, K equals 15. Good. So then they asked you to find Z. So Z equals K is 15, X equals -4, and Y equals 7. Perfect. -420. Yeah? All right, good. It was not bad. All right, try number 12. Number 12 is even better. Do they even want you to go further than finding K? Oh my goodness.
No, ma'am.
So easy. So K equals 3/2. Thank you, Jose. All right. Don't leave it as 30 over 20, right? You need to simplify your fractions, okay? Always. All right, did everyone get this? Do you have any questions? Okay. So this was an SOL question. You know what? I want to give you guys a few seconds. Read this. Try it out. We'll do it together, okay? Because I don't want you to stress about it. But just read it very carefully. Try it out. It's like you're taking the SOLs right now and you got a problem like, this has a lot of words. Just make sure that you just kind of pick through and take out the important things, okay? So, volume of a container varies jointly. That's what we want. Varies jointly. Okay, you can keep working. I just want to get the equation. The volume varies jointly with the square of its radius. Oh, they gave you variables here, right? And its height, h. Okay. Volume varies jointly. How many of you guys just put R? None of you.
I did.
What?
KR. Okay. Square the what?
We don't need it.
Square the R. Guys, square of its radius. Good.
What?
Right.
I told you. They'll do that. They'll do that. Square its radius. Okay? Just be careful. So the container has a height of 10. Height of 10. Radius of 6. Ooh, so 6 squared. Volume, so we don't know K. Volume of 377. Yeah? Okay, so let's find K. What is this? 360?
Yep.
Divided by 360, what do you get? Does it simplify to anything?
No.
So it's just this?
Yep.
377 over 360? Alright, well that's fine. Am I recording? Okay. So, if that's K, alright, let's go plug it in. So we have B equals 377 over 360. That's my K. R squared H.
Why is it R squared?
Because it says square of its radius R.
And after the second one?
Yeah. Huh?
Yeah.
But if you, it doesn't say it on the second
What do you
one,
mean? On the H?
it doesn't say it on the second one, but it's still squared because it says it earlier in the column, so it usually is there.
Oh, yeah. Like here, it doesn't say square. That's
no,
what you're saying?
No, the last
Yeah.
sentence.
So, here's
What
the
is
thing.
No, but what is the volume of the container with the radius of 4 cm and the height of it?
Yeah. Your first statement where you set up the equation, that is what you need to
It still
use.
holds true.
Okay? They're not going to say square the radius, square the radius, square the radius every single time. They're going to tell you one time, and you use that equation, and they're just going to tell you what to plug in for your variables. Do you know what I mean? All right. So, what is the volume of a container? 377 over 360 with a radius of 4. So if this is my equation, I just plug in the 4 for my r, but that has a square, and a height of 4. Yeah? What is it, 64?
No, 3016 over 45.
That is the answer.
3,000
and 6. No,
16.
and 16 over 45.
over 45.
And that's your answer.
That's it? That's
That's
such
it.
an ugly. Okay, what is the unit?
Cm.
Would it be
Cubic centimeters. There we go. Okay? And look, this was an SOL problem. It's not pretty. They're not always going to be pretty. Right?
We should make them pretty.
No.
You can rate it low.
Alright, so here's the fun part. Yeah, writing variation equations. All you're doing is just writing them. Alright? I mean, we need to practice some of these too. X varies inversely with Y. Ooh, and what? And
Ooh.
directly with Z. Oh my goodness.
Oh.
Oh no. Alright, let's try it.
I got
X varies
K over
inversely with what?
Y.
Y, but directly with what?
Z.
So directly means where does the Z have to go?
Top.
In the top. There we go. Okay, so now we're going to combine stuff. How exciting.
No.
What is inverse of this?
What are you laughing at?
So look at number 15. I want you guys to try 15, please. So Y varies jointly. So Y equals K jointly with what?
Z.
And
Square root of 2.
square root of X.
Okay.
Ooh.
Okay, square root of X. They didn't say square of X, they said square root of X. Alright, so be careful. Try number 16. Okay, now let's see. This one, varies inversely. And what? What's my other key word?
Jointly with
Jointly.
Y.
Alright. So let's see. W varies. Varies means equals K. Inversely. So where does X go?
On top, on the
On the
And
bottom.
Y is Z on the top
And Y and Z on the top. Why?
because it's joint.
Good. Jointly means it's like direct, right? Y and Z have to go on the top. Did you guys get this?
I did.
Good. If you did not get this, then just let us know, okay? We'll come over. Here's another SOL question. Another beautiful SOL question.
Beautiful.
Which equations match the following description? Oof. So you have to come up with the equation first, and then look at how all of these are equal to different things, right? Like you have df equals dk, dk, ds, right? You need to see which ones match your equation. Could be more than one answer. A car stopping distance d varies directly with s, oof, and inversely with what? F. Okay, it's a lot. Write that equation first, so you can use that as your basis.
Is there only one answer?
Choose all that apply.
I can only think of one.
I got 2.
All right, so we have D equals KS over F. Do you agree? All right, so this one. That one definitely, because that is the equation, right?
Isn't also the one above it?
All right, so look at this guy, DF. Well, if you took and you multiplied it by F, to make it, you know, df. Well then, df equals what? Ks. Oh, so you're right, Dylan. That one also works. Are there any more? Let's see. I'm gonna shrink this guy. Oh no. Why is this not locked? Hold on, I'm gonna lock it. Alright, so that one. How about this one? Does this one work? How about, nope, the other one doesn't work. This one definitely not. If this one equals D, then that one is not, right? How about K? If you solve this guy for K, oof, multiply by F.
Yeah.
So you have F equals KS. How do you solve for K? What do you have to do?
S.
Divide by S. So K equals DF over S. All right, that one works.
You basically use minus the one, then you solve it and you send it as simplify it.
Yeah. Right? Can you get DK together like this one, the second one? No, because you'd have to multiply by 1 over, right? And then it would just end up, nope, that one doesn't work. How about S? Nope, nope, that one's not going to work either, right? Let me show you that one. Equals KS over S. Is there a way for me to get DS together? No, no, right? Okay? So, 1, 2, 3 answers for this one. Yeah? All right. So that just kind of shows you just a little bit of what kind of problems you can expect to see on the SOLs, right? Look at the next problem, guys. Ooh, another SOL question. All right, I actually want you guys to try this one. I think you guys can do it. Take your... Okay, so body mass index, BMI, is directly proportional. There's that word. And inversely proportional to something else. Okay, so let's go see. BMI is directly proportional to a person's weight and inversely proportional to the square of height. All right, so I'll say B equals K, directly proportional to the weight and inversely proportional to height squared. Did you get this?
Yes.
Okay, all right, good. So a person with a BMI of 23.91 has a weight of 135 and a height of 63, which is squared. Okay, so it says round to the nearest hundred. What is the BMI of a person? Okay, so I need to find K. All right, so since I have this, I mean, I guess I could cross multiply here and then solve, right? What's that? 63 squared. Huh?
Yes.
2969.
3969.
3969
Yes.
is this
Yes.
times 23.91 equals 135K. Bless you. Right? Times 23.91.
48.79.
So divided by what? 5. So divide by 135. So K equals
72.96.
0.9.
6.
Oh, because it said 0.95. Let's say 0.95, right? Because it's 0.954, right? Okay. So then I have to go and rewrite this. So B equals 702.95 W over height squared.
Oh, that's what I did wrong.
Oh no.
Because when I got
Height
to
squared.
that point, I didn't put it back in the format. I just
Careful, especially when they give you a whole bunch of variables, and especially if they give you things like squares, square roots, stuff like that. What is the BMI of a person with a weight of 145? Weight 145. What's the height?
65.
Inches 65 squared.
24.12.
702.95. 145. So it says round to the nearest hundredth. 24.12. Oh, this will say BMI because I don't know what the units. What is this? Weight over, so what is that? Pounds over inches, right? Okay? All right. Good. So that's it for the notes.